I'm Mike Cronin, CEO of NodeH, the small cell software specialists. NodeH products available today support residential and enterprise small cells, UMTS and LTE, and in LTE we support both FDD and TDD on a range of hardware platforms. The dual-mode LTE plus UMTS enterprise solution supporting 32 users on each technology is our flagship product. The NodeH software includes everything that you need on a small cell, not just a protocol stack, but security, self-organizing network capability, device management, and software configuration. The NodeH software sits directly on top of the software that comes with the small cell system on a chip, or SoC. That software API was developed by the Small Cell Forum. It's called FemCell API or FAPI. NodeH integrates our software with the SoC software and thoroughly tests and debugs that integration so that the result is a deployable binary, which is configurable for different operators just by editing XML files. Because NodeH has written the software above the FAPI, if there is a specific customization required by an operator, then we're very quickly able to make that change. The demonstration I'm going to show today is a NodeH dual-mode software running on the most advanced small cell SoC from Qualcomm, the FSM9955. The 9955 incorporates all of the processing required for a small cell. It's housed on a single chip. It's this SoC approach that dramatically reduces the cost of the base station compared to discrete solutions. This is the Qualcomm development platform onto which we ported the NodeH software. Of course, the same software also runs on ODM platforms, such as this one here. This diagram shows the platform in context, with real UEs being used and emulators for the rest of the network. NodeH provides the diagnostic tools, emulators, and in-the-field tools which are necessary for robust deployment of a large number of small cells. The Qualcomm 9955 SoC has both LTE and UMTS software from NodeH running on it. So I'm now going to show you a 3G call. Let's start with two phones which have been intentionally camped on the 3G cell. We can call from one phone to the second phone. Hello. Hello. This is a 3G call using the Qualcomm platform. And then end the call. Looking at the trace, we see all of the signaling that occurred in the course of the call, such as the CM service request originating the call, the alert and connect messages as the call is established, and finally the disconnect. Similarly, you can do HSPA Plus with 21 megabits downlink and 5.7 megabits uplink, as well as supporting all categories of 3G mobiles from release 99 up until today. Now we've got an LTE Cat4 device which is camped on the LTE cell. We start to download, and quickly we see the data rate rise to close to 150 megabits per second. Here we are looking at an embedded web page, which is showing the transfer as it happens. The LTE software supports 150 megabits downlink and 50 megabits uplink, and this will be extended in the future. Now I'll launch a Volte call. The LTE system has been designed to prioritize the voice traffic based upon the class of the data, so it's no problem for the high-speed download to continue, and it has no impact on the Volte call at all. Notice the very rapid call setup time. Looking at the web page, we can see the download continues. But if we scroll down, we can see the two additional UEs have connections with uplink and downlink traffic. From the scaling, you can see that it's actually very little data. The data downlink continues to run, utilizing all of the free capacity of the cell. Taking a brief look at the signaling, we see here that the call is set up as an LTE data call, but notice the QCI1, which prioritizes the Volte traffic above the normal data traffic. The software supports 32 users for UMTS, and currently the same number for LTE. One of the advantages of the Qualcomm platform is that it opens up a roadmap to higher numbers of users and higher data rates. Also, the platform supports carrier aggregation, CBRS, LAA, and IoT. So going forward, the Node Edge software can support all of these technologies. I'd like to emphasize that the key to successful deployments is the code around the code that gets deployed. I'm talking about the regression test systems that ensure that when you fix something or add new features, that you don't break any existing functionality. I'm also talking about the logging systems that allow you to debug problems that occur in the field. Remember that over 3 million Node Edge-based small cells are deployed, so this is a particular expertise of Node Edge. So to summarize, what you've seen here is the Node Edge Enterprise UMTS and LTE software running on the Qualcomm FSM9955 platform. If you are an operator interested in such a product, why not contact Node Edge to find out more? Thank you for listening to the video.